Which of these do you think is larger? A rectangle of 5 cm square in size or a line segment of 15 centimeters? Well, the answer to that is that the question itself is wrong. Now, why is that so? To answer that, we need to know what the word dimension truly means. According to the International System of Units, each of the 7 base quantities gets its own SI unit, which defines the scale of measurement for that unit, and its own dimensional symbol, which sort of is used like a nickname to just describe that particular quantity. And the dimensional symbols for the 7 base quantities are sort of like that for length, time, mass, temperature, amount of substance, electric current, and luminous intensity. And using all that, you could define any random quantity and see how it varies with any one of the 7 base quantities one by one, and to what extent it varies with any one of those quantities. And in most cases, come up with a proper relation between that random quantity and the different base quantities like length, mass, time, etc. So here's an example. Let's say I define something called f and say that it depends on length, mass, time, something like that. And using symbols like m, l and t for mass, length and time, I could get a relation between f and the remaining things like f equals ml by t square. And say I decide to represent this part alone as a. Now this relation can be rewritten as f equals m times a. And from that you can see that every single physical quantity has its own unique dimension fixed. And that dimension can be written as a combination of the 7 base quantities. And not just that, it can also be written as a combination of, say, a base quantity with a predefined quantity, like I did with f equals ma, where a is my predefined quantity, which also can be written as a combination of the 7 base quantities. And this is valid only as long as the combination gives you the exact same dimensions of your physical quantity. So what I'm trying to say is that the equality sign, on either side of the equality sign, you need to have quantities of the exact same dimension, regardless of what sort of combination you're representing that physical quantity as. Well, the equality sign itself is just a special case scenario when both the quantities you're comparing have the same value, so you can replace that with a lesser than or a greater than symbol when the values aren't equal. In other words, to compare any two things, the dimensions of those two things must be the same, regardless of how they're written as or whether they're equal or not. And that is the main idea behind something called dimensional analysis. So back to the question that I asked in the beginning. The reason it was a wrong question was because on one side of the comparison we had a rectangle of area 5 centimeters square, which means that quantity area had a dimension of length power 2. And on the other side we had a line segment of 15 centimeters, which means that the quantity length had, well, the dimension of length itself. And it was as meaningless as comparing say the mass of this bulb here with versus the light that it emits, because of the fact that you can only compare two things as long as they have the same dimension. Hey there, thanks for watching this video and I hope you liked it. If you feel this video could be helpful to someone, then feel free to share the link with them. And if you're new here, then I suggest you have a look at this video to know what this channel is all about. And if you're waiting for the next one, then click here to subscribe and stay tuned. And I will see you in the next video.